Okay, this is the 2009. This is the 2009 macro. Or sorry, 2009 micro number 2. Okay, and this is the one about the excise tax and elasticity. So we're going to do all of that, and I'm also going to show you the 3 ways that you could figure out the elasticity, which would be C. So I'm going to do C last, so I can show you those 3 ways, so I can erase this. Okay. So here is the graph, and you guys should have it in front of you. But here is the graph. Calculate the producer surplus before the tax. Okay. Well, right here is our. So no tax, here is where supply hits demand, okay? So we know that the base is 90, and we know that the height is 2, right? So essentially, this entire area, right, is going to be our producer surplus. So the height would be 5 minus 2, so the height would be 3, right? So if you're looking at figuring the area of this is just 1/2 base times height. So 1/2 90 times 3. So 1/2 of 270. And so it's 135. Okay, so that's how to do A. So for B, assume that we have a per unit tax of $2. And we can tell this because you can see that it stops here at 4 and starts at 2. So it's a $2 per unit excise tax. Okay, calculate the amount of tax revenue. Okay, so at this new tax, so you can see again, you can see that because there's a tax, the amount of quantity goes down to 60. Right, we're moving up the supply or up the demand curve with this new supply curve, and so now our quantity is 60. So when we have this tax added to this market, the market demand is only 60. The quantity demand is 60. The tax is 2. So the government's collecting $2 every single time they collect a good. Every single time the consumer buys a good, the consumer is buying 60 goods. So it's just 2 times 60, or 120 would be the consumer surplus. Would be the tax revenue for the government's going to collect. And then it says, what is the after-tax price the sellers will keep? Okay, so on this one, you know that this is the supply curve with no tax. So when the price goes up to $6, this is the new $6 is the new price, right, with the tax. So you can see that the quantity hits the hits the original supply curve here. So the actual sellers are only getting $4. So originally the sellers were getting $5. Now the sellers are only getting $4. So the sellers are getting $4 every single time they sell a good. And $1 of that's being sold. This amount is being passed on to the producer, and this much is being passed on to the consumer. It's actually even because the graph, I have it looking wonky. Calculate the producer surplus after the tax. Okay, so after the tax, you know that the producer's only getting $4, and they would only sell it at a minimum of 2. So now this becomes the producer. This is the producer surplus. So in this case, again, it's base times height. It'd be 1/2. And the base is 60, so 1/2 60 times 2. 4 minus 2 is 2, right? So 1/2 of 120, and so the answer for this one should be 60. Let me check, see if I'm right. Yeah. So so that's what's happening as the producer surplus. It was all of this, right? So it was all of this. Now with $1 going down, it's a little bit less, okay? And then letter D, assuming no externalities, does this tax affect allocatable efficiency? Yeah, it definitely does, because taxes make it less efficient. In fact, here is where it should be, and here is where it is. So this area right here actually is the dead weight loss. And if there is dead weight loss, that means it makes it less allocatively efficient. Okay, so that's A, B, and D. Let me do C real fast. So let me make sure I got that right for you, by the way. The market's no longer allocatively efficient because the producer and consumer surplus, we call the total surplus or the total human welfare, goes down. All right, so there are three ways we can do the elasticity. We can do the total revenue way, right? And so total revenue between here to here, right, at $5, right? Total revenue at $5, all right, was 5 times 90, which is $4.50, right? And then we go up to $6, so we've raised the price, and 6 times 60 is $3.60. So when there's an increase in price and it leads to a decrease in total revenue, that means it's an elastic good, okay? That's one way to do it. That's the total revenue way to do it. Another way to do it is just simply to find the percent change. And it's the percent change in quantity over the percent change in price. Percent change in quantity, we go from 90 to 60, right? So that percent change is, from 60 to 90, or 90 to 60 is 33%, right? And then from 5 to 6 is 20%. So you can see if you divide 33 by 20, you're getting, more than 1. And remember, if the elasticity is more than 1, it's elastic. So the percent change shows it's elastic, total revenue shows it's elastic, and then finally you do the midpoint where you do Q sub 2 minus Q sub 1 all over Q sub 2 plus Q sub 1 divided by 2. And the same where the sub 2 is always the bigger number. Then P sub 2 minus P sub 1 all over P sub 2 plus P sub 1 divided by 2. So this would be 60 minus 90 would be 30 all over. This would be 60 plus 90, which is 150 divided by 2 is 75. So 30 over 75 equals, this would be 6 minus 5, which would be 1 all over 6 plus 5, which is 11 divided by 2, which is 5.5. Okay, 30 divided by 70 is that 0.4? I think it's 0.4. I'm doing it in my head, so I might be off. Use your calculator. Is that? Yeah, and then it goes in 5 times. Yeah, 3.4. And then 1 over 0.55, I think that's 0.18. And again, you divide 0.4 by 0.18, and it comes out to more than 1. So the midpoint formula, the percent change formula, and the total revenue way all tell us that it's elastic, and they would take any of those things. Any one is fine.